In this video, we are going to discuss Rolle's theorem. Before we start, if you think my video is helpful to your study, please click the like, give me a subscribe, and then share this video to your friends and peers. I appreciate your help really much. Okay, what is Rolle's theorem? Let f be a function that satisfies the following hypotheses. Number one, f is continuous on the closed interval AB. Number two, f is differentiable on the open interval AB, and then fa is equals to fb, then there is a number c in AB such that f prime of c is equals to 0. So let's take a look at number one and number two, continuous and differentiable. What does that mean? Continuous, number one, that means there is no discontinuity, right? So continuous from A to B, that means you are not going to see what? You are not going to see a vertical asymptote, all right? You are not going to see an open circle somewhere between A and B. And then what about differentiable? Differentiable means you don't see discontinuity, like you don't see a vertical asymptote, you don't see a sharp point, you don't see a cups, right? Those are not differentiable. And then number three, fa is equals to f of b. Fa is equals to f of b. Take a look at the picture right now. That means a and b, they have the same y value, right? So a and b have the same y value. That means I can draw a horizontal line to connect a and b. So at x equals to a and x equals to b, we have the same y value. So let's use the first picture. This is also the first case, and the very special case, I can draw a horizontal line to connect a and b, just like that. So look at this horizontal line. This is a constant function, right? The slope is equals to 0. So the function is continuous and differentiable between a and b, and f of a is equals to f of b. And then I can say that there is a c between a and b such that f prime of c is equals to 0. F prime of c equals to 0. That means at x equals to c, the slope of the curve or straight line at x equals to c is equals to 0. So since this is a horizontal line, it doesn't matter which point you pick between a and b, the slope is always equals to 0. All right. So the second case is we have a curve. So we start at A and then ends at B, right? So now you can start drawing a curve, but you have to pay attention to this. No vertical asymptote, no open circle, no sharp point, no cups, right? So that means you are going to draw a smooth curve. No sharp point, no cups, no vertical asymptote, all right? So what if you have a curve that looks like this? All right, and then f prime of c equals to 0. When I say f prime of c equals to 0, does that remind you something about critical point? All right, so critical point, at that point, f prime c is equals to 0 or f prime c is undefined. So that means at that point, we either have a maximum or a minimum. All right, so let's say this is at point C. All right, at point C. What do we see right here? F prime c is equals to 0. That means at x equals to c, we have a horizontal tangent. All right. So what about this one? How about this curve? And then at this point, when x equals to c, we have f prime c equals to 0. We have a horizontal tangent. So that means at f prime c equals to 0, we have a maximum or a minimum, right? So can we have a maximum and minimum at the same time? Yep, sure. We start and end at the same y value. We can go up and then we go down. So at this point C, right here, and then this point C, we have f prime of c equals to 0, and that c is between a and b. So that's how the Rolle's theorem works. Let's solve a quick example. So in the next page, I have a problem for you. Verify that the function satisfies the three hypotheses of Rolle's theorem on the given interval. Then find all numbers c that satisfy the conclusion of Rolle's theorem. Okay. So what is the first thing that we have to check? The first thing that we have to check is, you can go back to the top of the video, continuous and differentiable, right? How do we check continuous and differentiability? So this one, continuous. How how do I know this function is continuous between -1 and 3? So this function f is a second degree polynomial, right? So that means the function is continuous everywhere, of course, including from -1 to 3. So that's why the function is continuous on -1 to 3. Another way to say this is between -1 and 3, you can choose a value between -1 and 3 and then plug it in. The function is always defined. All right. So number 2, this is a parabola, right? So a parabola is differentiable everywhere. So f is differentiable from -1 to 3. All right. And then what is the next thing? The next thing that we have to check that f of number 3, we have to check that f of -1, f of a is equals to f of b, right? How do you check that? You plug it in to see if they have the same value. So f of -1, so that is 2 times -1 squared minus 4 times -1 plus 5. So that is 2 plus 4 plus 5. 9 plus 2 is equals to 11. And then f of 3, so we have 2 times 3 squared minus 4 times 3 plus 5. So we have 18 minus 12 plus 5, that is also equals to 11. So number 1, number 2, and number 3, they are satisfied. And then we have to do the f prime c equals to 0, right? So f prime of c, and then I believe that they are asking what the c is, right? So we have to set that f prime of c, I don't know what that c is, so I'm just call that x must be equals to 0, right? So can you take the derivative for me? That is very easy. So you bring the 2 down, then you have a 4x. The derivative of 4x is equals to 4. The derivative of 5 is equals to 0. So you set the first derivative equals to 0 and then solve for x. So that is 4x equals to 4. Then x is equals to 1. And then the last thing is 1 between -1 and 3. Yes, so -1 x is equals to 1 is in from -1 to 3. All right, so that's how you check the Rolle's theorem. All right, so that will be all in this video. In the next one, I will show you the mean value theorem. I see you in there.